Hi guys, so today we're going to be looking at using recursive rule with sequences part 2, and we're going to be looking at the translating rules and changing them from explicit to recursive rules instead. Okay, so in this case we are given a explicit rule, an equals to -6 plus 8. And we have an equaling to -3 times 1 over 2 to the power of n minus 1. And we want to change them into the recursive rule format. So let's start off with the first one. If you can see from our explicit rule, I can automatically tell that this is the arithmetic rule. So I'll write down that this is arithmetic. If we're looking at arithmetic rule, then I also know that our formula provides us with our common difference, which is always multiplying with n. So in this case, our common difference is 8. D should equal to 8. Once I have that down, I also need to identify what my a, or my first term is. So a sub 1 would equal to -6 plus 8 times 1, and that equals to -6 plus 8, which is just +2. Cool. So now that we have our first term, we also know the value of our difference, we can create our formula. So my formula for the explicit rule for arithmetic series is an equaling to an minus 1 plus d. I know that now the given is going to be a1, giving it to be 2, and the only thing that I'm really changing from my explicit rule is the d. So I get d, or an equaling to an minus 1 plus 2, or sorry, not 2, the difference was 8. And that would be my final answer. You're just getting the given from the first term, and you're also getting the difference, and you're just changing that. Cool. Let's look at the next problem. So the next problem over here, we have an equaling to -3 times 1 over 2 to the power of n minus 1. So automatically, I'm assuming that this is the geometric since we have the exponents given to us and the format of geometric series. This also means that we already know that our rate is going to be 1 over 2. Rate is always inside that parenthesis. And then from there, another thing that I could do is find out what my first term is by plugging it in. 1 over 2 to the power of 1 minus 1, that equals to -3 times 1 over 2 to the power of 0, which would just equal to -3 times 1, which is just -3. So once I have my first term and I have my rate, I can rewrite it into the format of the recursive rule. So our formula is an equals to r plus an minus r. The only thing I'm really changing here is going to be my rate. That's it. My given is that our first term is equal to -3, and I'm just going to enter the r value for 1 over 2. And that's multiplying with an minus 1. And that would be my final answer. Okay. All right. Next one, we're just going to do the opposite. So you have recursive rules, and we're changing them to explicit rules this time. So let's say that you have the recursive rules right here, and we're changing them to being explicit. First identify, do you have arithmetic or geometric series? In this case over here on the left, we definitely have an arithmetic series. This is the formula for the arithmetic. And because that's the formula for the arithmetic, automatically I know that this right here, the -2, is going to be my difference. So d does equal a -2. Once I do that, I can use the formula an equaling to a1 minus n plus, or minus 1 times d to figure out what my explicit rule is. So my first term is given to me already. It's -5. Then my difference that I found was -2. And so all I'm going to do is simplify it now. So distribute the -2 to both terms. That gives me -5 plus -2 n plus 2. And then I get -2n minus 3 as my final answer. Okay, that would be my arithmetic formula or rule. Cool. Alright, let's look at the next one. Next one over here on the right side. Automatically, we do have the formula of the geometric rule. So I'll write down this is geometric. And in that formula, we automatically know that 2 is supposed to be identifying our rate. And then we could just write out our formula for the geometric series. An equals to the a first term times r to the power of n minus 1. So we get an equals to 10 times 2 to the power of n minus 1. Nothing else we could do. That would be the end of our answer. Okay, so hopefully this helped. Good luck.